Hi, here we have a beautiful geometry question from Iranian Mathematical Olympiad round number 1 in 1997. We have an isosceles triangle ABC, AB is equal AC, BD is the bisector of angle B. We know that BD plus AD is equal to BC, and the question is, what is the measure of angle A? The question was multiple choice questions, and these are the options. Normally for these type of questions, you have approximately 6 minutes per question. I suggest that you spend maybe around 10 minutes to solve this exercise, and after that, come back and see the solution. All right, because we know that BD plus AD is equal BC, the first thing that comes into our mind is that we should create a length equal to this AD on BC. So we select point F on BC so that FC is equal AD. And in that case, we know that BF will also be equal to BD. And we know that because BF is equal BD, this is an isosceles triangle. These two angles will be equal. All right. So sometimes in geometry, you need to create new lines in the geometry in order to gain additional information. So that is what we are going to do here. We introduce a parallel line from point D to BC. This parallel line intersects side AB at point G. Okay. Because this one is parallel with BC, we know that this angle is equal to this angle. And since BD is bisector, we know that this angle is equal to this angle. Therefore, these two will be equal. That means GD is equal GB. So these two sides are equal. This is what I have written here. These two are equal. We also know that since GD is parallel with BC, the ratio of AD to AC is equal to AG to AB. This is what I written here. But we know that this ABC is isosceles, so AB and AC are equal. These two are equal. That means AD and AG must be equal. So AD and AG, they are equal. If AD and AG are equal, that means DC and GB are also equal. So actually, this GB is equal to GD is also equal to DC. All right. Now, if we look at these two triangles, we see that DC is equal to GD. This angle is equal to this angle because these two are parallel. And FC is equal to AD. So these two triangles, they are identical. This is what I have written here. These two triangles are identical. And because of that, we know that the angle DF is equal to angle A. This is what I have shown in this picture. We know that this angle is equal to angle A. Let's look at angle DFB, this angle. We know that this one and this one are equal. So the summation of these two will be 180 minus this angle. And if you want to find one of them, it will be 180 minus this angle divided by 2. So angle DFB is equal 180 minus DBF divided by 2. All right. On the other hand, we know that this one is equal to angle A. So angle DFB is also equal 180 minus angle A. That is what I have written here. So instead of DFB, I can write 180 minus A. And we can multiply. This one comes here is 360 with 180 disappears. 2A can go the other side. So we know that 180 degree is equal to 2 times angle A minus angle DBF. All right. What else do we know? We know that this angle is equal to this angle, and this one is double DBF. So angle AGD is 2 times DBF. This angle itself is 180 minus A divided by 2. So I can write that this one is equal to 2 times dBf. We can take the 2 the other side. So angle dBf will be 180 minus angle A divided by 4. So this one is 180 minus angle A divided by 4. Now I can put this one into this equation and basically we'll be able to solve the measure of angle A. So 4 will be multiplied to both sides. This we have 4 times 180. This minus 180 goes the other side. So we will have 5 times 180. 4 times 2 is 8. Plus 1, 9. So 5 times 180 is equal to 9 times A. This with this disappears. 20 times 5 is 100. So angle A is 100. The correct answer is option A. So what we have learned is that draw the shapes such that the geometry fulfills the description of the question as close as possible. Because if you draw the geometry properly, you might notice that certain sides are equal to the other sides, or certain angles are equal, and then you try to prove them. The second point is to introduce new lines in the geometry and try to obtain extra information by comparing the newly created shapes. This is very important. In complex geometry questions, you always need to create some additional structure and gain extra information from those additional structure. And final one is to know and be able to use well-known theorems in geometry. Why I wrote this one here? Because we have to go back. So I explained that how we obtain this angle is equal to this angle. We could also achieve this one by another way. We have the bisector theorem, which says the ratio of AD to DC, this is the bisector, the ratio of AD to DC is equal to ratio of AB to BC. Okay, so the ratio of AB to BC is actually equal because AD is equal to FC is equal to ratio of FC to DC. And since these two angles are equal, we can say that this big triangle and these small triangles, they are identical. And you could immediately conclude that this angle is equal to this angle. So this information could also be obtained by knowing the bisector theorem, which states that the ratio of AD to DC is equal to ratio of AB to BC. So you must know and be able to use the well-known theorems in geometry. So sometimes they can help you to find a solution faster. All right, this is the end of the video. See you next time. Bye.